HVAC 360 is brought to you today by the Big Bad Wolf Corporation and their new product, Breeze in a Bottle. This innovative product is not to be confused with those puny cans of air that clean off keyboards. These high-volume, highly processed canisters of 55-degree air are perfect for those places that come up short during and after the balancing process. Just hook it up to an existing diffuser and go. They are guaranteed to last through the warranty process, so your firm is in the clear. Don't huff or puff. Get your Breeze in a Bottle today. Hey, what's up? Welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. We do that by sharing stories, interviewing experts, and really giving you more HVAC knowledge that you can shake a stick at. In addition to this podcast, you can always double down on your weekly dose of HVAC knowledge by going over to HVAC360.com and signing up for the newsletter and joining the community of people just like you. All right, so what's up for this week? This week, we're going to talk with a testing and balancing expert, Mr. Mike Mazzolini, who's the Director of Operations over at Fulton & Associates Air Balance. We got a lot of subject matter to cover, so we'll just cut to the tape with Mike Mazzolini. All right, today we're talking with Mike Mazzolini, who is the Director of Operations. He's the NEB certified professional over at Fulton & Associates. How are you doing today, Mike?
I'm good, Matt. How are you?
I'm fantastic. Hey,
living the dream.
Absolutely. So you've been around the industry quite some time. Why don't you tell me a little bit about your background in balancing?
Here's a funny thing. I just did receive my 25-year watch from Sheet Metal Workers Local 33, plus I have an additional 5 years as an apprentice. So I have about 30 years dedicated solely to testing, adjusting, and balancing. I hold the NEB certification for, we're a NEB certified testing, adjusting, and balancing firm. There is a process that has to be gone through to, of course, become NEB certified. There are written examinations and practical examination that needs to be completed within a certain period of time. I also serve on the technical committee of our chapter of NEB, which is the Ohio Kentucky Environmental Balancing Bureau. And I attend conferences both at the national and chapter level and stay involved heavily. And I'm also a certified proctor so that I actually can participate and help with not only practical examinations for certified professionals, but certified technicians as well.
Just so everybody kind of has a little bit of reference there. When we talk about NEB, the National Environmental Balancing Bureau, they're kind of just generally here in the United States, one of three typical organizations that or associations that support the balancing community. You have the AABC, you have TAB, but NEB is the one that you belong to. And being the NEB certified professional, that actually means quite a bit because you are sort of like the person at your firm that's really overseeing all the operations, all the different balancing that's being performed. Everybody else can be like a technician, correct? But you are kind of overseeing everything.
Yes, that's correct. And I also help. I mean, not only that, but I know we'll get into some of the instruments and staying on top of calibration of equipment and things of that nature. But yeah, when I like to be a problem solver, so when there are issues that arise, I like to participate and, provide solutions. That's really what I get most of my enjoyment out of And I like the people, even some of them that are peculiar. I like people in general, and I like to communicate with them and help provide solutions at the end of the day.
Yeah, so your life is pretty busy on a day-to-day basis, I'd say.
Just a little bit, man. It only took me a month and a half to get back to you about this, and I know we had talked a little while. So, but yeah, it can be hectic at times, but it's a good job. It's a very interesting job. You're always switching gears constantly. From simple things. All the way back to, I just got some questions on, we have some younger guys coming up, and they had some questions with some pneumatic VAV systems that they were working on. And at times that could be complicated, especially if it's something that you're not used to. But if you understand the basic concepts of how that VAV controller is supposed to react, it's actually really more on the simple side to troubleshoot. But it takes time to understand and get to that stage in your career where you can be confident with troubleshooting. Something as simple as a pneumatic VAV box. It's kind of funny. I'm kind of going off on a tangent, but even at the national level, they wanted they talked about doing away with, having any kind of questions on the tests about direct acting, or normally open, reverse acting, normally closed, whatever the case may be, background. And I actually kind of piped up and I did say, I said, if you understand how to troubleshoot and understand how a pneumatic VAV box works, it's pretty similar to a DDC box. So if you pull a high line and that motor doesn't go open, it's not getting the proper signal. So that backbone knowledge makes you a stronger troubleshooter with the new equipment that comes out, because you have the background of how it's supposed to function. I guess that's the best way to put it.
Right. Absolutely, and I think it's a simpler system, but yet just knowing, it's one of those things you can easily get wrong, and it's simple enough to know. But it's like a lot of things in our industries that are kind of going by the wayside. I'm sure that there's less emphasis put on steam systems and things like that on the engineering at the engineering level, just because it's all either hot water, chilled water, or refrigerant. But so it kind of falls into that same category. I'd like to go back to the one thing that you did mention, that you were part of or you are part of the local 33 sheet metal union. Is that something that's common? I mean, so there are union shops and non-union shops as far as testing and balancing go?
Yes, more so in our area is a strong union area. There are some competitors, namely in the Columbus area, that are non-union. But yeah, overall, all of our guys, including myself, I'm signatory to Local 33, and hold the certification for our company. The beauty of that is we actually don't. I mean, the hall does have classes that the techs can take if they want to. I am more stringent, where I've been doing a chapter a month with all of our up and coming young people. This gives me a better understanding of where my guys stand at the end of the day. It's not like you couldn't call the hall right now and ask for a test and balance guy. They don't exist. You follow? So like if you said, well, I need a sheet metal guy. Well, yeah, you could call the hall and they would be able to support that potentially, or provide you a contractor. But yeah, our training we like to do it in-house. Now, we do have a beautiful facility, which you've been at, Matt, at Local 33 in Cleveland. They have a fantastic test and balance laboratory, and we've put on a number of presentations there, just kind of showing some of the processes that we go through in the field, so to allow people to get a more eyes on that, hey, what do these guys really do? What, anybody with a flow hood's a balancer. Well, you got to be careful with that too, because, a lot of times you have to know when that equipment can be utilized. So to understand when you may be getting a bogus reading from a flow hood, especially on a supply register. I've seen that mistake happen before, and I guess this kind of jumps down to some of the other stuff that we were going to talk about as far as mistakes in the field. But you have to know what procedure you need to use for that type of system. I mean, if it's a 2x2 lay-in or a 1x4, yes, a flow hood is a good device to use to measure the air volume. But if you get into a situation where there's registers and you're not getting a real even velocity across that, the flow grid within the hood will not read accurately. So you'll get some. It'll actually read higher potentially in many cases. So you have a bogus reading, and the only way to back up what you think is actually happening is, of course, going back old school and performing a pitot tube duct traverse, which, basically the two methods, equal area and log Chevy-Chef, which we don't got to get into, but, there's procedures that we need to follow as test and balance people so that we can provide accurate data that is repeatable in the field.
All right.
For balancing and or troubleshooting, because, we all get into situations where, hey, there's a problem. We need to come up with a solution or provide the best advice of, how can we work through this? So I guess that kind of got on a tangent on that one. Sorry.
It's okay. So, and again, I want to go back to this one last time with the union shop. So typically, is that something that you're going to go into the testing and balancing industry, you hook up with a testing and balancing firm, and they're like, okay, now you got to go sign up with a union. We're going to train you as an apprentice in-house. So you're not kind of...
Yes.
Okay. So that's
yeah. So typically, we've picked up a couple guys that were in the Local 33 as a sheet metal worker. They had a couple years in. The guy is sharp, mathematics skills solid. We ended up taking him in, and he's worked out fantastic. But typically, people will come in and apply. If we have an opening where we can put an apprentice on, I believe you're allowed. I believe it's one apprentice to 3 journeymen. So these guys aren't going out into the field on their own. They're being trained by guys that are, have a wealth of knowledge and background and experience in this field, and they're getting their training from that. And then I'm backing it up with the book side of things through the NEBB study course. And we go through a chapter, and eventually they'll go through and they'll take their testing as a CT.
A certified technician, right?
Yes. Mm-hmm.
So let's go there a little bit. I mean, as far as getting out into the field, what do you really do as a test and balance somebody going out into the field? What do you do to kind of prep for that? What's the process for test and balance?
Well, first we need a PO. I mean, I'm just saying. But yeah. Typically, what we'll do is a lot of our clientele, it's direct. It all depends. Sometimes it's for a mechanical contractor. Sometimes for the commissioning agents. Sometimes for the CM, so on and so forth. But typically out of the gate, what we do is we, of course, request the most current drawings, because I can't tell you how many times I've been told I have the latest and greatest drawings, and, guy gets to the job and he's like, no, that's not what's here. So I always request that the most current drawings, the specification, and of course the equipment submittals. From that point, that job will be ready to be set up, which is basically taking the drawings from drawing form to report form. So at that point, we'll have somebody set that job up, and at that point, they would put in the pertinent data that is required for a fan sheet, or a duct traverse sheet, or an air distribution sheet, or a pump sheet, or water pressure drop element sheet, or a temperature sheet, depending upon what we're dealing with at that time. The other thing that I always like to do is analyze the test and balance specification. I'd like to stay tight on the tolerances. I mean, some of the hospitals can be pretty tight, and you have to, when you're pricing that job, you have to understand that, plus or minus 10%, okay, plus or minus 5%, that's going to take some tuning in and dialing in, and potentially going through systems 2 and 3 and 4 times if needed. I mean, imagine a large ducted return system in a hospital. That's always brutal to balance, and those are some of the other things that we can talk about later, where you have this monster ducted return system, and you're trying to distribute the air, and you don't have branch dampers, or there were no details showing branch dampers, and we can get into that later. So I always like to definitely take a hard look at that, and also provide the technician with the calibrated instruments that he's going to need for that particular job, or if there's specialty items like some of the other test instruments that we have, where there's situations where we can't measure measure the water flow by pump curve or pressure drop of a component. We've actually invested in a couple of GE PT878s we've had for a while. We just got another one, but
and what is that?
Those are that is it's an ultrasonic flow meter.
Okay.
And it has all kinds of capabilities of data logging, totalizing. So, like, if you needed to know how much water is being consumed, domestic cold side in a facility, we can actually mount that and data log it over a 7-day period, and you can see when everybody's doing their laundry, and when they're using the restrooms, or when they're cooking, or whatever. So, very interesting. But it's another piece of equipment that kind of sets us apart from our competitor, where they'll just come back and say, well, there's nothing we can't measure it. There's no ports available, or there's no ports on the pump, or we can't find a pump curve, or whatever the case may be. So we try to think outside the box and figure out ways that we can get it done.
So if people haven't been familiar with or have seen like a test and balance report, you've mentioned that you take a look at the the design data, you take a look at the submittals, and you're going to put that information down on your sheets, because ultimately, when you look at the report at the end of the day, you're going to be comparing. You're going to go down the list, and you're going to see, okay, here's the value that the engineer wanted, and here's the value that you actually measured.
Right. And the beauty of the report is once you really understand how to read a report. Like I can look at a report and it's like, oh, okay, yes, this makes perfect sense. Or, whoa, something's wrong. This VFD, there's no way that this VFD is programmed properly. So that the report is typically set up with the type of fan and fan data, and then there will be a separate column with the motor data, which is of course very important. Down below, we have design data, and that data should come from the HVAC schedule. We also compare that data with the submittal. If there are discrepancies, we note it or bring it to somebody's attention that, hey, this could be a potential issue, based on what we're seeing. And it's nice because it's caught early enough on the construction process that it can be corrected without massive disruption, where you might get a report at the end of the job that says, oh man, this is the wrong piece of equipment, or whatever the case may be. It makes it for a cleaner job at the end.
So what kind of mistakes do you see that happen on the drawings? I mean, when you're setting them up, when you're taking a look at them, what sort of things that pop out commonly when you're taking a look at it?
The most common thing that I see is I like to focus on the detail drawings. And when I some of the things that I've seen in the past is one, pressure temperature ports and balancing valve locations on some of the drawings. The pressure temperature ports should be directly at the suction side of the pump, before the strainer. I see details where they're actually downstream in the strainer. I mean, it would be great to have it in all three spots, because then you could actually take a pressure drop across the strainer if you're having a flow issue. But that's probably one of the major ones. And what happens is, then the mechanical looks at it and says, well, that's how the detail shows it. That's how I'm installed. That's how it's going in, And I said, well, it should be here and here, for accurate measurement, when you're trying to determine the GPM by pump curve. That's one of the things. And typically, most of the rest of it, if it's not covered in the details, it's written, you'll see it written somewhere that it will call for, a balancing damper at each floor, main, sub-branch, however it gets worded in the spec, So sometimes we have to fall back on that, because like those large ducted return systems that we see in hospitals, it can be very difficult to balance if you can't distribute the air and work it like you would with a good duct installation that does have branch dampers throughout to get the air to where you're going to need it at the end of the day. It's difficult to balance a system. Yeah, every one of them has a volume damper, but a branch damper at the end of the day is going to allow you to distribute the air better, and it's going to reduce leakage that you would see typically, because when you're running a leakage test, typically your pressure, putting it under negative, or positive pressure, and that leakage isn't going to show up until after the rest of the duct's installed, which is a whole nother. I think you could do a complete podcast on that. We can do that later.
Absolutely.
But I don't know. Does that make sense?
Yeah.
That's really about it. That was just something that just jumps out to me that I see quite a bit lately for some reason. And it was just something that I jotted down while I was reviewing some of the questions.
Yeah, I think that you mentioned what I would refer to as the big hairy note. basically putting dampers where they should be, and just it's at least to me that's a little bit of a sloppy engineering. That you'd have to go back to the spec and try to beat somebody over the head to say, hey, you missed this because it should be there and you didn't put it in. Well, who's supposed to know that? That's that's one of those things that I just you should put it in there, but you shouldn't have to rely on it. That's at least that's my opinion.
Right, I would agree.
Yeah. So talking about specs, you said typically we're looking at plus or minus 10%, right? That's kind of the kind of industry standard.
Yes. Mm-hmm.
So, and you can get some different variations of that. You can get the plus or minus 5%. Right. I've even heard cases
0 to plus 10 on air handling equipment, and
right.
And then you look at the connected load of a constant volume system, and the numbers are off. I mean, we've seen that, and that happens. But at that point, to me, one phone call is equivalent to 22 emails. If you can open up the lines of communication, even with the design engineer, it makes things go a lot smoother, because you open up those lines of communication and you can understand the point where the engineer of record is coming from, and he can understand your point that hey, here's where we're at. We're really, if you're very focused on the numbers, be careful. I mean, another notorious thing that I see is, for some reason, let's say let's just call it a small ducted return system. And when you look at the unit total and the minimum outside air required, and then you look at the return total, and the return total matches the supply fan total, I always write in our reports, I still put, if let's say it's two inlets, okay, 2 inlets at 100 CFM, and it requires 100 CFM outside air. So we got 300 CFM total that we're working with. You got each of the 2 return inlets on the drawing show it wants 150. But if you account in what the minimum outside air requirement is, which it should have all the time, I typically put a notation on there, because 1, I'm not going to be able to be within tolerance of the spec, and 2, it's a notation that doesn't need to cause confusion. It's just a statement that says here, proportionally balanced with available air, accounting for the minimum outside air requirement. And usually that's not an issue, but those are some of the other things that I guess I see sometimes. And, I don't know if you have an opinion on that either way, but, just on a constant volume system, it could leave somebody scratching their head if they're looking at it and trying to properly proportion the system.
Right. The engineer really didn't do their final bit of math that they needed to do to say, okay, here's what the system's really gonna be at.
Well, right, too. And then, I mean, it's even like, it's similar with the return fan. The return fan is designed the same, but yeah, the actual intent is you want to pressurize this building. You don't want to relieve the remainder of that air. You want to slow that return fan down so that it's not infiltrating. You're not relieving any air out of the building, unless that's the design intent, and that would all get into the sequence of operation, which we can get into later, because it kind of falls into some of the other stuff. As far as did you ask me how I feel about the balancing specs? We're kind of in the midst of.
Yeah, exactly. Tell me what you think of the balancing specs.
I'm going to say overall they're okay. There are some cases which people label boilerplate specification, and it's not really specifically written for that particular job. One of the other oddball things that always jumps out to me are on the duct leakage specifications, and how they can be written very peculiar at times, where it says to, and this is one that I have, and hopefully nobody's on the phone that wrote this, but it says pressurized duct to 1.5 times the duct construction pressure. So, oh, I'm not kidding.
What?
So in that case, if I know who it is, I call them and say, look, I'm going to pressurize it to the duct construction pressure. I don't want to jeopardize the integrity of the ductwork by trying to provide you 1.5 times this, because it would probably need additional reinforcement before I could even think about doing that. The other thing is there's sometimes confusion where the responsibilities overlap with the mechanical contractor, where the mechanical contractor is supposed to perform the duct leakage test, and then it typically is witnessed by the test and balance contractor. Others write it where it's specifically, that the mechanical contractor shall cap and provide and support the duct leakage testing, and the duct leakage testing should be performed by the tab contractor, and then be specific and say, per SMACNA standards, is usually the most simple way to put it, in my opinion. But yeah, I do get some off the wall things, but overall, not too bad.
Yeah, I mean, it was always my kind of opinion and feeling that the specifications were generally way too long, a lot longer than they needed to be, because they'd go into the details of, okay, for this piece of equipment, I want these 40 things. And you've already specified, hey, I want the balancer to be certified either by one of the 3 agencies. So they already have their set of standards that they have to follow per their guidelines. So a lot of that stuff is just a little fluff. I mean, obviously, it's very important to be detailed about, where you're, the pressure testing, the duct pressure testing. It's very important about what the intent of the accuracy of the plus or minus 10% or something else.
Right.
And then, generally speaking, if there is some sort of other pressurization tests that need to take place, whether they be room pressurization tests or anything specific like that, that's very project specific, that should be in there. But with details of, hey, because a lot of times, it'll even in the room integrity tests, Matt, you'll see perform room integrity test, and then it's like, okay, well, what type of room is it? You know what I mean? So you kind of almost have to be a detective, go through, understand the system that you're working on, look at the offsets that based on the design, and say, okay, I need 100 CFM offset between supply and exhaust or return, and I have to maintain a 0.02. So at that point, then it's very specific. I can look at it and I can usually decipher. And then in that case, if I have a question, if it's somebody I know, I just call them and or it could be cleared up with an RFI or whatever the case may be. But yeah, if it got specific for that particular project and it's that detailed, I agree. It would be nice to see that there. And have you ever gotten a call from an engineer saying, hey, you know what, I'm writing the specification. What kind of things do I need to make sure that I specify, that I don't leave it too general? Has that call ever came through?
Absolutely.
So
yes, especially on duct leakage.
So to all the engineers out there, find a test and balance agent that you know, and that you can know and you can trust, and ask if you have the question, ask it.
Right. And I'm a phone call away, so I mean, if I can answer somebody's question, I'd be happy to do that.
Excellent. Yeah, because actually, now that you mention that, I'm like, well, I mean, we have listeners all over the United States. Fulton actually does work, pretty much countrywide, right? All the United States.
Yeah. We just we finished up a couple facilities in California, laboratory facilities, Kentucky. Yeah, we've been all over. I've had the luxury of working in Las Vegas.
Rough.
one time. Ohio, Kentucky, West Virginia, Florida. Yeah, I've been around. So we do travel. Especially for there's some companies and contractors and engineers that use us exclusively for the most part. New York is one of them. We've done some stuff at some facilities in New York to look at things for the engineer of record on some jobs there. So, but yeah, we can go wherever we need to go. And the beauty the beauty of our company is that we are solid with troubleshooting capabilities. Where you might be able to find a test and balance guy that might be able to balance the system potentially properly. I mean, you would expect it. You're paying somebody to perform a service and complete a job and do it right per the plans and specifications. Yeah, we do that, but we also can solve problems and figure out issues with equipment and get the right people involved when you do encounter those types of situations.
Excellent.
So, right, that's my plug, man.
All right, so but getting back to now that you've gone through, you've set up the job, you've gotten all the information that you need to. What kind of you're loading up the truck? What kind of equipment do you bring to the job site typically? I guess you can talk about it air side, water side. Those two things.
Yeah, we could start with air side. And I'm just pretty much this is. Of course, since we're a NEB certified firm, we're required to own the test equipment, and it has to fulfill and has, of course, its function, its minimum range, its minimum accuracy, and its minimum resolution. And typically, that piece of equipment does come if you pay for it. Of course, you have to pay for it, but it comes with NIST certified calibration data that can be provided at any time, because I can't tell you the importance of that. In fact, I think it was 2 years ago, Matt, I helped put on the presentation at the Ohio, Kentucky for the continuing education, on the importance of having calibrated test equipment. If you're competing with, a guy that's got a flow hood, he's got no certification, goes in, he balances a building, and and there's problems, and of course they're going to call in the guys that can figure it out, and it's usually us. And one of the first things I go out to and I say, well, I met the guy out on the job, and I said, well, show me what you're using to test this, and he's got a Velgrid from 1960, that's got its original calibration data on it, and I'm like, when's the last time this thing's been looked at? But even it's so important from energy consumption to changing shifts, because you're relying on a tachometer that is NIST certified, calibrated, functions correctly, provides you the correct data. You have to be able to be smart enough to look at that fan RPM. This is a belt-driven application, let's just say. And you go in, you tack that fan RPM, and it's 690, and you look at with calibrated amp probe and voltmeter. We typically use like a fluke setup where it has a lot of the equipment has multi-functions in one unit, and we can get into those in a second. But it just you're going to use your fan laws. Of course, you're going to look at fan curves at times, depending upon the type of fan. Is it not overloading? What can I really do at the end of the day to solve this airflow problem? And I'm relying on all this equipment to come to that conclusion so that I can order the proper material and also in conjunction with reviewing the submittals, so to not exceed the fan critical RPM of that fan. I can't tell you how many people have said, well, just speed it up. Well, I can't, the motor's loaded, or just speed it up. I said, no, it's at 3,200 RPM. The critical RPM by the manufacturer is 3,215. We can't go anymore without jeopardizing the structural integrity of the fan. So that I think puts in perspective is the importance of that. But as far as without a doubt, and even for safety reasons, you don't want somebody going into a panel with a meter that's not calibrated or working, and somebody getting hurt. First and foremost, a lot of times we have to de-energize equipment. There's times where we run across three-phase equipment that's running backwards. If we can, we play well with others. If we can get an electrician to do it for us, we do it. If it's a dangerous situation, we put it on a punch list and let whomever we're working for chase the proper person down to get the rotation corrected. But and again, all these things should have been done prior to us coming out. So startup should be complete, and everything up and functioning and ready for testing and balancing. Controls complete, so on and so forth. Everybody goes through their process. Okay, boxes are up. They verify that they're reading airflow. They verify that the motors are the damper motors and control valves on the hot water reheats or chilled water coils, and everything's supposed to be up and functioning and checked out before we pretty much step foot on site. But we know that doesn't always happen, unfortunately. So let me get back to the instruments. I kind of went off on another tangent, Matt. You got to reel me back in sometimes. Typically, so we have a tachometer, of course. We use stitch tachometers as the manufacturer we typically go for. As far as electrical measurements, without a doubt, we go with the Flukes 373 clamp-on meters, and that's, again, a multi-function piece of equipment. As far as air side goes, I'm strong on Shortridge. I've worked with Shortridge. I've talked to Shortridge. I've asked questions to Shortridge. They've been very supportive. Their test instruments read into the minimum accuracy required. Some of the facilities we work in, clean rooms and things of that nature, we're recording differential pressures, down into the 10,000ths range. So very accurate, very detailed. That Shortridge ADM 870C, there are a couple other models out there, but typically the 870C is good for testing and balancing. Its other multifunction, of course, is it'll measure velocity, pressure, and feet per minute, and again with the same amount of accuracy within a minimum resolution of 1 feet per minute. Also has a Vel grid and also a Vel probe, which can measure higher velocities depending upon. Sometimes you may have to measure the velocity at the inlet of a fan because there's an airflow station there, so you're trying to confirm calibration. Sometimes you can tee into that equipment so that you confirm that your velocity pressure is matching, or velocity test and feet per minute is matching what's being displayed through the building automation system. And ultimately, at the end of the day, I mean, if you're going in there and you're not using quality equipment to test instruments to measure this equipment, at the end of the day, that data is being used in conjunction with the building automation system to try to save energy. So you're kind of shooting yourself in the foot if you're not following proper procedure and proper calibration procedures by the manufacturer or recommended yearly calibration. I do it yearly. Some of them say that it's only required on a 2-year basis. I don't want to take that chance, so I do it yearly. And I also keep a fresh set of test instruments that don't leave my office, so that if somebody has a question or a hunch that something is not functioning correctly, they can bring it to me and I can cross-check it against a piece of equipment that's never left my office. So that's kind of how we combat that. Direct hood is another function measurement that the Shortridge ADM 870C will do. For additional fee, you can purchase a base with the flow hood grid in it, and they have up to 5 top sets. We typically use 5 top sets because we do a lot of hospital, pharmaceutical, where we may need to, have a hood that can get a measurement on a 2x4 opening. Some require Vel grid measurements. It all depends on the type of facility. On the water side of it's mandatory that any NEB certified firm has to own a rotating vane, which is very good because there's some manufacturers, kind of getting back to our talk about the flow hood not reading accurately. Sometimes the manufacturers will provide published data as part of the submittal of what type of instrument you should use to measure their type of diffuser, drum loop, or whatever the case may be. Usually you can find that information if you dig deep enough. I think that pretty much sums it up for the air side of things. Of course, we have air temperature, immersion, air in contact with high resolution, and large capabilities, because we're measuring. I mean, I've measured some ovens and things of that nature. It's now Masco cabinetry, but it was craft made. I used to spend a lot of my field time out there and measuring temperatures of ovens that would help their curing process to the cabinets and things of that nature. So you got to be diversified with the temperature measurement. On the hydronic portion, we use a combination of Alnor, and we have typically more Shortridge HDM 250s. And that is the beauty of that is it's a multifunction measuring device. And it can measure pressures individually as well as differential in inches of water, psi, feet, inches of mercury, and so we stick with those because some of the balance valves that are out there, you have a wide range. And again, the more ways that you can test a piece of equipment. So, for example, let's just say a chilled water coil. You know, the detail shows a very nice setup, shows a balance valve on the return line. We of course measure that, and then they've also, you know, if you look at the details, if they leave it there, if there's pressure temperature ports where you can get a pressure drop through the coil, that's also helpful, you know, for troubleshooting. I can't tell you how many times we've seen strainers, you know, the infamous strainers that can plague water systems, and how quickly they can plug up, especially if there's still construction strainers are installed when, you know, we were told construction strainers are out, system's been flushed, we're good. But we kind of run into those situations. It's always nice to see pressure temperature ports across components, especially like a bag or a basket strainer. I just worked on one not too long ago here. I had all the pressure drop ratings for this. I measured it, and based on my measurements, and that's the other thing I want to stress is any test and balance guide, just never ignore your readings because they're going to tell you everything. And the beauty about this calibrated test instrument, I can take that pressure drop, and I know that I'm at half the water flow, and I know my pressure drop is going to go to the square of the flow if I had the correct flow. And I'm supposed to have less than a half a pound drop across this basket strainer, and I've got 10 at half that. So it came out to like I would need like 83-foot drop across that basket strainer to have the correct flow. And then, you know, and then I go to the installing contractor and I'm like, hey, the strainer's plugged, man. Oh no, we just pulled it. She sent me pictures. I said, well, it's plugged again, you know? And that's the thing with strainers. They, you know, it may take 4 or 5 times of circulation. You know, you gotta stay on top of it because I can't tell you how many times pipe has gotten dropped off in the mud to a job site. It gets slapped in and it plugs up at the reheat coil or chilled water coil or whatever the case is. And, you know, the guy tells you, oh, I pulled a strainer, I cleaned it, it was dirty, put it back in, you know, it was fine for 5 minutes, so I walked away, you know, and then I come back and I come to it and it's plugged again. And I'm like, man, you got to, and I said, no, you have to sit here and you need to let this thing run, you know, even over a couple-day period, because those pipes have not seen that water velocity because they were put in so dirty. So it's going to take time as the pipe starts to see more and more velocity. It's going to still collect at the strainer. So it could be a tough process at times.
Oh, I totally can see that. Yeah, absolutely. It's not like they wash the pipe when they put it in. They, you know.
No, yeah. So it can be brutal, and it's like, you know, we're typically the bearers of bad news sometimes, you know.
Yeah.
But you know, at the end of the day, we want it right, and we want it to work, and we want everybody, of course, wants the customer to be happy with the job that they got. So
right.
So that kind of sums it up.
Yeah. So let's talk a little bit about that. I mean, the test and balance guys can work for different people. Obviously, they can work directly for the owner, or they can work directly for the contractor, the HVAC contractor, which was, had typically been the way that happens. What do you think? What are your feelings on this? What are your opinions, pros and cons?
I got to be honest. I'm kind of all over the board on this one. If you have an owner that's involved, that would be the way to go. I've had great projects, Matt, where I've worked for the architect, I've worked for the engineer, I've worked for the commissioning agent, I've worked for the mechanical, sometimes even the control people. For some reason, there was some strange jobs where the testing and balancing was under the control contractors. The construction manager is a good one, because if everybody's working for the CM and I send a punch list to the CM, it's up to him to kind of try to track that guy down. But what I like to do at the beginning of the project, and again, it takes time. You get to know the tradesmen, and if I have a problem, it's more cost effective for me to have my tech talk to the guy in the field and say, look, I need a damper here, or this is installed wrong. What can we do now? And 99.9% of the time they're receptive. There are some times where they're not receptive, and I'm like, well, you can fix it now, or you can fix it when your boss tells you to fix it. It doesn't bother me either way, but the report's not coming through until this is corrected, or I can balance it because you're missing components, or whatever the case may be. And it's kind of wild because, like I've said before, we're kind of the liaison between the electrical contractor, the controls contractor, commissioning team, engineer, architect. Who am I missing? Pipe fitters. Sometimes plumbers. Depends on domestic water systems. It depends. But yeah, I mean, we work for them all. I guess if I had a favorite, I'd probably lean towards the commissioning agent too, because I mean, in your line of business, Matt, you get a sense of comfort that you got a team on this that's going to do the job, first of all, and not get a bogus report, and so again, I know I'm kind of all over the board with that.
Yeah, it's ultimately, at least from my standpoint, it's one of those things that if you work, you don't want to be ignored. You don't want to have your opinions and the information that you find kind of pushed down and not brought to light. And you need the problems addressed. And so if you if you're in the wrong position, you don't necessarily get the leverage, and that's if like you're talking about having the owner being engaged or whoever being engaged, as opposed to just not doing anything about it.
Right. And and the other thing, I mean, from a commissioning standpoint, a lot of times, we can generate these lists, and those lists actually become part of the commissioning log. Is kind of a good approach that has worked for us in the past. That hey, this data's out here. Now you've got commissioning, construction manager. You got all these people in positions to delegate who needs to do what, or who needs to take care of what. But I like to run the jobs, with communication, and hey, if we can solve this problem now, it's going to be easier on you. It's going to be easier on everybody. let's just address it now. And most people are that way. I mean, there's been a handful where, I'm like, look, you can fix it now or you can fix it later. It's up to you. I want to get this done, or I could just send a punch list in. If I'm working for the mechanical contractor and it's a sheet metal item, I send it into the MC and he sends it over to the sheet metal guy, and then the sheet metal guy, and this is all documented, via punch list, so that I have this data to fall back on and say, well, I've been back to this. You've told me twice it's been corrected. I'll go one more time, but after that, it's got to stop, because I don't have unlimited funds to go back and keep telling you that you didn't do what you were supposed to do, unfortunately. So
right.
So yeah, I'm kind of in the middle of the road on all of it, I guess, as far as. But there are some definite cons, because your data is not getting lost by the MC. It's documented by us, as well as the commissioning team. So it's kind of a good approach.
So just to kind of put a bow on this conversation, what sort of advice for somebody who's listening and thinking about getting into testing and balancing? What sort of advice would you give them?
I was going to say don't, but don't. I'm just kidding. I'm going to say this is a very unique, specialized trade. Yeah, it's a trade that you could get into and you could follow through with, and it's something that physically you would be able to do and still do and retire from. So I'm committed. I like what I do. I like the people that I work with. It's a very unique situation. I guess out of the gate, understanding the fundamentals of things is the first key. The other is focus on the calculations and understand where to apply the calculations so that you become a good troubleshooter. Because once you do that, it's like, whoa, everything just makes sense. You definitely need to be focused on NEB procedural standards and testing methods, and what is the most accurate method to follow. It's a hands-on job. It's unique because you get to solve problems. I think it would be good for anybody, even if their ultimate goal would be to become a mechanical engineer, it would be a good thing for any young mechanical engineer to even, come on or shadow or anything of that nature, with a test and balance guy, because it'll just make you a more solid engineer than you already are, because you're getting the hands-on experience and you'll see some of the trials and tribulations. I mean, the other thing is this is constantly changing. It's unique. You have hundreds of different control programs that you work with throughout calibrating equipment. You're working with all these different trades and professionals, controls people, electricians, and at the end of the day, you're understanding how sequences of operation are supposed to work, and it actually allows you to look at it, and once you master some of those things that I mentioned on early, you become a better troubleshooter, and you even can take it to the point where you're so far into what the equipment can and can't do, you may realize that, oh my God, if you look at this, there's not even a control point for, a purge mode that a fan system's supposed to have. I just ran into that situation previously, drop me a resume if you're interested.
We'll put that in the show notes. I think the one interesting thing that I realized a couple of weeks back is that, or at least was brought to my attention, because I never really thought about it. I guess if I would have thought about it, it would have been very blatantly clear. But test and balancing people aren't contractors; they're actually consultants, and that was something that was, because you associate them with contractors because they're involved in the construction process. So you're like, oh no, just another contractor, but they're not. They're actually consultants. Right. And the reason I know that is somebody pointed out that it's the type of liability insurance that you get. When you're a contractor, it's very specific that you get this type of insurance. When you're a test and balance company, you're in a completely different category, which is more reminiscent of consultants, engineers, architects than it is of contractors.
Interesting.
So,
okay.
All right. Well, I'll leave with that. Mike, any closing thoughts that you have?
No. I mean, if it's a unique situation. Again, you get to work at some of the most unique places in manufacturing plants and hospitals and clean rooms, and where all these unique processes happen. It's really an interesting field. You're not working at the same place every day. There is some travel at times, and you get to work with very interesting people. And I like to give back and teach everything that I possibly know to my guys, and my guys, they train the apprentices the same way. So, and we've got a great group of guys, so we're very fortunate.
All right. Well, thanks for coming on, Mike. I really do appreciate your time, and
thank you.
And we'll probably bring you back for some other episodes. So I think there's a lot of things. We've just touched the tip of the iceberg here, and there's a lot of different things that we can talk about related to test and balance.
Sounds good, Matt. Thank you again.
All right. Thanks again to Mike Mazzolini for taking the time out to chat with us. Check out the show notes for links and things that we mentioned during the interview. You can find those show notes over at hvac360.com/134. Since for 134 for the 134th episode of HVAC 360. Well, that's it for this week. Thanks so much for listening. I hope this was helpful. If you or somebody else you know are looking to get more information on the tab, the testing and balancing that goes on, consider passing this along for them. I know it would be a great boon to your network and help everybody share and grow the show. Also mentioned, please subscribe to my list over at hvac360.com. And the last two things, I would be greatly honored if you'd go over to iTunes or now it is Apple Podcast and leave a rating and review. That would help so much to get the word out about this podcast. In addition to that, we are also simulcast on YouTube. So if you go over there, even if you listen to the podcast normally just on your podcast app, go over to YouTube and subscribe. Search for HVAC 360 and see the episodes there. Just hit subscribe. Once I get enough subscribers over there, I'll be able to do a couple of interesting things over there. All right. That's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.